All right, everyone, thank you. Good afternoon. My name is Wes Garner. I'm the chairman and CEO of GLC Minerals. Welcome to today's final Knowledge Nook, a presentation called Magnesium Matters, Putting Solubility to the Test. I'm pleased to welcome Dr. Noelia Silva del Rio, herd dairy specialist at UC Davis. Dr. Silva del Rio recently published a key study in the Journal of Dairy Science evaluating bioavailability of 5 magnesium sources in non-lactating Holstein cows. Her findings offer practical insights for improving mineral supplementation, herd health, and feed efficiency. During this session, she'll cover the role of magnesium in dairy nutrition, differences in solubility and bioavailability, and strategies to enhance mineral status. Please join me in welcoming Dr. Noelia Silva del Rio. Thank you.
Thank you. I hope you can hear me. Yes. I'm going to be moving, so if you have any problem with the sound, just let me know. First, I want to thank you, GLC, for sponsoring my graduate student with the work, and also to the members of the technical committee that GLC has. It has been an amazing experience for me as a researcher, working with people like Jesse Goff and Bill Weiss, designing the studies and the future strategies for learning more about magnesium at the end. And first, what I'm going to share with you is the results of the study that we conducted 2 years ago and we published last year. The title of the study is Relative Availability of 5 Inorganic Magnesium Sources in Non-Pregnant, Non-Lactating Holstein Cows. And I'm going to walk you through this study. But first, I'm going to do an introduction about magnesium. And probably most of you know about the importance of magnesium in nutrition and what is the importance. Biological functions of magnesium, including it is a cofactor in more than 300 enzymes, which means that if you don't have enough magnesium, somehow some of the key enzymatic pathways are not going to be working. Bone formation, everybody knows that. Muscle and neurological functions. Everybody has heard about hypomagnesemia in dairy cows and cows not moving, similar to hypocalcemia, and also calcium and phosphorus metabolism. Has anyone heard about the importance of magnesium in human nutrition? Yes. Yes. And is it associated with vitamin D? Yes. And some people it's aesthetical, it could be. But if you think about the importance of magnesium, and magnesium is necessary for the proper function of vitamin D, and you know how important is vitamin D in multiple functions, so it's key at the end to have good levels of magnesium. How we manage magnesium in the blood, the homeostasis, we depend on intake. So meeting magnesium requirements depends on the daily absorption of dietary magnesium. So if you are off feed, for whatever reason, you're not going to have enough magnesium, because it's really hard to mobilize from the bone. Yes, we have magnesium in our bone, but it's not going to be ready, as calcium and phosphorus can be. Where is absorbed? In ruminants, in mature cows, it's absorbed in the rumen and the reticulum. And whenever we have an excess, we have the kidney. The kidney is going to be the gate. We have an excess of magnesium in the system because of the intake. We are going to have a higher magnesium in urine. How we can check magnesium availability? And that is a little bit tricky because early studies were able to do isotope work where you just label magnesium, you feed it, and you find where it goes. But now we don't do those type of studies. Because the kidney function, as I mentioned before, when you feed over the requirements, the magnesium is going to be excreted in the kidney. What we decide is just to check availability relatively to other sources based on the excretion of magnesium in urine. So that's what we did. We fed the same amount of magnesium with different sources. And the sources that we decided to test were sources that are commonly included in dairy cow rations. Magnesium oxide is the #1 source, I think everybody will agree. Calcium magnesium carbonate, calcium magnesium hydroxide, and magnesium sulfate. And here I have the different absorption coefficients that NASEN has guided us for formulation. And we picked these sources because we thought that those will represent what the industry is feeding today. One of the things that I want to mention before I move forward with the study is that we had 2 sources of magnesium oxide we tested the first source for solubility in vitro, and it came up with a low solubility, so we identify another magnesium oxide source that it was higher in solubility, and that's the one that included. Why the magnesium solubility may vary from source to source? It could be because of the calcination process, how it's processed, the particle size, and also the chemical composition. Here is a picture from a paper that I took, and you can see the difference, microscopic difference across different magnesium oxide sources. These are 3 different magnesium oxide sources that they have different particle size. In our study, as I mentioned before, we tested multicium, that is a novel alkalinizing proprietary blend of minerals, and I just abbreviate as PNB. That source includes magnesium. You can see here it has calcium at 33%, magnesium 8%, and the components are calcium magnesium carbonate, calcium magnesium hydroxide, and magnesium oxide. Multicium has been commercially developed and studied both in vitro and in vivo. There are studies from the University of Florida and now studies also from my lab. The in vivo availability of magnesium from PNB relative to other commonly used magnesium source has not yet been evaluated when this study was done, so that was our objective, just to learn more about the availability relative to other sources of the magnesium PNB. So our hypothesis is that the relative availability of magnesium from PNB will be comparable to other magnesium sources. So we chose, as I mentioned before, magnesium oxide, calcium magnesium hydroxide, calcium magnesium carbonate, magnesium sulfate, and we compared the relative availability with PNB. We used non-lactating, non-pregnant dry cows in our study, and we use a Latin square design. What it means is that we have the same cow exposed to all the treatments in different weeks. So 1 week we will have the 6 treatment going in different cows. So we have 2 squares, what it means 6 cows, 1 square, other 6 cows in a different square. So each given week we have 2 treatments, same treatments going to different cows, and then we just randomize the way that the treatments were allocated. What offers that is that basically all the cows were given the same treatment different times. That minimizes our variation due to the cow variability. That's why we choose this design. And we had a 14-day adaptation period. As you know, cows vary in intake, and they were moved to this research facility, so we want to have them accommodate, stabilize the intake. And what we calculate is the 90% intake. We calculate the intake that the cows were having last week prior to the study. And we fed them 90% of the intake that they were eating the week before of the study and the enrollment. We did that to avoid the cows were one day eating a lot and the other day eating little. So we had restricted, fed restricted. This is the composition of the diet that we formulated had 0.21% of magnesium and 0.17% of potassium. To administer the treatments, we use this device. We put the magnesium sources, the different magnesium sources in bolus. We calculated 30 grams of magnesium from all the sources. And for some sources, we need to give the cows 4 boluses. From other sources, only 1 bolus. And here is the study design. On day 0, we consider that the enrollment date, we weighed all the cows. So we had the body weight. And at day 2, we fitted them with a urine catheter. And then we checked the volume of urine. So we were collecting urinary volume. On day 3 to day 5, so it was a 48-hour period that we split in 12 hours. So we have 4 times 12 hours. And we collect the urine volume, and also we collect samples of the urine. And then we also took blood samples, but after the bolus administration. As you can see here, the bolus were given on day 4, and we just follow the cows after administration of the bolus for 24 hours. Here is the setting, how the cows were housed during the study, and you can see here the catheter that is collecting the urine, and here is where the urine was collected. And we took that every 12 hours and replaced with a new bottle and combined all the measurements. The outcomes that we measured was intake of magnesium, the urine volume, urine magnesium concentration, adjusted magnesium concentration was another outcome that we measured, and we calculated that based on the, so I mentioned that the treatments were given on day 4, but we have the magnesium urinary excretion on day 3, so we subtracted that to the, what happened after, and the serum magnesium concentration. I'm going to skip the statistics here. Here are the results, and first I want to show you how the particle size and surface area of the sources that we use look like. And you can see that we have two sources that they were fine particles, that it was the PMB and the calcium magnesium hydroxide. And here is the surface area that we have, and here we have the distribution of the proportion of particles that they were the 25% lower side are here, and the 25% particles that they were higher than this are here. And then at the end we had the solubility that it was measured at pH 6. It was titrated with acetate in the lab, and you can see the solubility now of these values that ranges at 1 hour from 93.9 to 8.3, and we go to 24 hours, and you can see, as expected, the solubility in vitro increase. So this is normally, this is quite easy to get in the field, the solubility of the magnesium. What we wanted to check is, are those values again the same when we look into the cow? And that's what we did with the in vivo study. We have a source, calcium magnesium carbonate. You can see that the solubility in vitro was considerably lower than the others. Let's see if also sustained in vivo. So when we look at the different sources, it's important also to know how much calcium and magnesium each of the sources were providing. And that's the reason why we had to give 4 bolus for one of the sources, because only provided 80%, and other sources was enough with just 1 bolus because they provided 48% of magnesium just in and the calcium, the same thing. Some sources were really high in calcium and others were not. Here are the treatments, the dry matter intake of the cows. As I mentioned before, we try to feed those 90% so we don't have those jumps up and down during the study. And here are the intakes. Like biology, they are not all the same numbers, but they are pretty close, no statistical difference. When we look at the magnesium intake will include what they ate from the diet plus what we gave with the mineral supplement. So here is what the cows ate in the control group. You can see that is significant. 26, and is different from all the other treatments, which is expected. And here you see that we have all these samples that are pretty similar in content of magnesium, close to 56. And we have one sample magnesium oxide that is a little bit lower, is 7 to 10% lower than the other doses. And the reason is because we did not measure, we based our calculations on the label. We did the measurements after the study. For some reasons, maybe it's hydroscopicity, we don't know, but the amount of magnesium that the sample had was lower than what we were expecting. The urinary output is key in our study because we are measuring how much urine it goes out and the concentration of magnesium in the urine volume. But you can see here that this is prior to the study, the urine volume, but after the study, on those 3 treatments, there was an increase, significant increase in output of urinary volume with the magnesium source, those magnesium sources. Here we have the results, and maybe this is a different way that you are used to see magnesium availability data, so I'm going to walk you through. So we have the collection from -24, so this is the data from the day prior to giving the bolus. Here is when we give the bolus, and then at 12 hours after the bolus, and at 24 hours after the bolus. I'm just going to ask you to pay attention to the gray line, that is the control, that is the lower one. So that is your reference, that is the treatment where we did not provide any supplemental magnesium. And you can see that is the line that it goes lower. And if you look at the calcium magnesium carbonate is the second line that is pretty close to control. And in our study, there was not a difference between magnesium in urine, between those two, the control and the calcium magnesium carbonate. And you see here, if you have the same superscript, it means that they are similar. And when we go to the other source, what we can see is that they are pretty similar. You see those three lines kind of behave the same. They go the same pattern. And magnesium oxide seems just to keep catching up over time. We stop the data at 24 hours. This source also seems to be increasing over time. If we continue our study, maybe we have different results here, but we don't have the data. And here is a way that I think most people is used to see the data. And what we did here is basically we subtracted these grams from this information. So we just get one value. And if you want to just see the combined 24 hours the data is the gray bar. If you want to see how it goes from 12 to 24 hours, you see the blue is 0 to 12, 12 to 24. And you can see again the same pattern. Again, all B's, what it means is statistically, at least statistically, they were not different. And these two, again, were similar. I don't know if anyone has a question so far here. The results about zero magnesium, I have to share those with here, but are a little bit messy, as you see here, lines, and what are messy. So the treatments that they have high calcium, that is calcium magnesium hydroxide, PMB also has high calcium. You can see that those treatments have a different behavior, those two lines. And we hypothesized, we didn't check this, but because they were also supplying high calcium, and calcium can affect the PTH, high levels of calcium, so it will be downregulated PTH. We hypothesized that maybe the magnesium values were affected by the changes in PTH. We did not measure PTH, but that is our hypothesis. Everybody knows that zero magnesium can give us an indication of it can give us an indication of serum status, but when we are overfeeding and feeding extra calcium should not be a good measurement of deficiency. This is at the end one of the key pieces that I think the industry could use, but I don't think we should emphasize the results because it's just one single measurement for solubility. I think this is too perfect to be real. I did this, I didn't fake the data, but in biological, I think if we do this study, we don't get the same correlation. This means the correlation between the solubility in vitro with the viability that we find relatively, availability that we found in vivo. So it's extremely good. I think in vitro studies can give us an understanding of what we are dealing with. I'm not sure if they are going to be always holding this correlation so high. When we measure at 1, so I had measurements of solubility at 1 hour and at 24 hours. The correlation was not as strong with 1 hour, so I just described here the 24 hours. But if this was true, this would be just telling us that we can just rely on the in vitro analysis to guide our choosing our sources. The conclusion from this study is that the supplementation with 3 commonly used magnesium sources and PMB resulted in a similar increase in urinary magnesium excretion, except for calcium magnesium carbonate. What is important is that although magnesium sources rich in calcium resulted in lower blood magnesium concentration at 12 or 24 hours postpartum, this is probably not going to happen. This change that we saw in blood with these sources is not going to happen when you formulate the diets and adjust for calcium. When you adjust for, nobody's going to feed the diets so high in calcium, but those were our study design. Now I'm going to share other studies that we are doing, sponsored by GLC. My student Jorge Bermeo is leading those studies. I also have a collaborator in the research and extension group, Rubia Branco Lopez. And what we are doing is trying to get the nutritionist perceptions about magnesium feeding and also put into test solubility of magnesium sources. So what we are doing. So our objective is to understand nutritionist perception and needs regarding magnesium in dairy cow diets, evaluate magnesium solubility from commercially available sources, and this is in vitro, not in vivo. In vivo is too expensive. And evaluate the agreement of different solubility tests, because there is a little bit of disagreement across tests. Why is this important? There is a paper from the year 2003. It was done also in California, Tulare. And I don't know if probably many of you know Santos. Dr. Santos was Overton, Phil Jardon, and the first author was Jose Urdat that came to do a sabbatic there. So this is what they saw. A herd with 2,000 dairy cows. During one summer, they had a seasonal problem with suddenly now cows were affected. They were mid-lactation. They have basically, these are the same clinical signs that are clinical hypocalcemia, but we don't expect that hypocalcemia in the mid-lactation. And the clinical signs were very rapid. They died in less than 1 hour. There were 6 deaths. And 3 cows were able to be saved just by intravenous calcium, magnesium, dextrose, and oral magnesium sulfate. So the diet with silage, corn, barley, alfalfa, cottonseed, soybean meal, canola, mineral supplement, they were providing 0.28% of dry matter from magnesium. And they adjusted the diet with magnesium to 0.54%. And the next year, they still experienced some hypocalcemia, even though they were feeding 0.40%, but they had variable dietary potassium in the diet. One of the things that they needed to check is the solubility of the magnesium sources, because probably the solubility of this source that they were feeding, or this one that is the same, probably was not as desirable as it should be. In this study, I encourage you to read that, because they have a second case study where they went the other direction. They overfeed magnesium due to a protected protein, and at the end they have diarrhea for 14 days, just 1 day of high magnesium feeding, 14 days of diarrhea, 4 kilos of milk drop. This is another study. It's from Europe, where they are evaluating the different solubility and techniques to evaluate solubility in vitro from magnesium outside. The reason why I want to put this here is that you can see that the bars are in different lengths. What it means is simple. The solubility in vitro changes from sources. So there is a huge variation. So you call everything magnesium outside, but when you look at the solubility, it may change. And the technique also is important, because if you see, the gray is batch culture with artificial rumen fluid, and the white and blue lines are with vinegar test. Probably you all know the vinegar test, which you just acidify the sample. So you have a newsletter article that we put together, and if you know any nutritionist that wants to participate, we have 2 things that I want to show you in this newsletter article. Here is a video that my student put together on how to do the vinegar test in the field, and this is a survey link that we encourage the nutritionists to participate. So we have already done this. We communicated with ARPAS. We reached about over 500 nutritionists in the United States through ARPAS, sent an email. We didn't offer any reward. I think we will have a gift card. Probably the response will be different. So far we have 32 responses, so if you want to increase your sample size, that will be great. We had 10 questions. It takes 3 to 5 minutes. The areas that we are covering is demographics, magnesium source selection, dietary formulation targets, and health observations related to magnesium. And we also give the opportunity to nutritionists to send us samples. Of the 32 samples, I'm just going to give you a snapshot of what we found. This is the distribution demographic of the responses. 11 nutritionists used 2 different magnesium sources, but you can see that the biggest split is between magnesium oxide and calcium magnesium carbonate are the 2 preferred magnesium sources of the participant nutritionists. When we asked about if they were concerned about the quality of the magnesium sources, half of them responded that yes, they were concerned. 84% say that they were interested in knowing the solubility of the magnesium sources. And when we asked how they chose the magnesium sources, most of them, they said that it depends on the feed meal availability. Some, they said that it was based on quality, and a few just on price. What are the targets of magnesium? And you can see here that most of them are following in the 30 to 40%. Anyone has a comment here with this? So we have the outliers, that the people that is feeding very close to nothing or closer to the nothing target, and others that are feeding almost twice or over twice of what is recommended. Anyone has a guess what is happening, why we have those variations in the field? I guess we need to do a follow-up. Of course, we need to ask, when we ask about magnesium inclusion in the diet, we need to ask also about potassium. And here is in winter, we are in winter and in summer. And here is the summary of the winter values that they were feeding in winter. They were for dairies, nutritionists, that they did not change the potassium in the diets summer versus winter. But you can see here that in winter the recommendation will be 1 to 2%, and you can see that most of the nutritionists, so they are kind of above of requirements. And in summer they increase to 1.2 to 1, these are the recommendations, sorry. In summer, I think they increase approximately 25% more the potassium levels. The health observation, this is quite interesting because nearly 30% of the nutritionists that responded, they had reported hypomagnesemia in mid-lactation cows, or they have suspected to see it occasionally. 70% never saw that. So throughout reaching out to feed mills, reaching out to nutritionists, we have compiled a list of the different magnesium sources that we are planning to evaluate. We are going to present the data anonymous. We are not going to disclose. We are going to just do, when we summarize of in vitro solubility, we are just summarizing this. But if you think that our list is incomplete and we are missing some sources, please reach out to us or send us the samples, because that will be really helpful before we start our study. What we want to do is send to 2 different labs, try to see the methods agree, the different labs agree. And just want to mention that we have here one of the posters. This is a pilot study. We have some samples that we already summarized and present this year at ADSA, but this is not going to be the final study. Those are samples that GLC had get hold of, but they are not a complete of the all sources that are available in the market. But what we did is evaluate in vitro versus with the vinegar test. These are the diamonds, and in vitro solubility with pH 6 at I think it was 1, 8, and 24 hours. Interestingly, magnesium is catching up because at ADSA this year there is also another work for FeedWorks, and they are also working with Cumberland Valley Analytics, looking at methods of in vitro analysis of magnesium solubility. So I think we might be making progress on magnesium solubility between 2 groups working on the same goal in the near future, which I think is going to be important for the industry. And with this, I just want to give you here my information, and also Agustin Delgado from GLC. You have questions, and again, if you have any way to increase our sample size, or any, it will be appreciated. And if you have also samples that you want to submit, again, thank you. Any questions?
If you do have any questions, just raise your hand.
Yes.
Thank you. Maybe I understood on the opposite, but the urine magnesium that we were expecting as output is the magnesium that wasn't absorbed, or not?
Okay.
Because I saw higher levels of
Yes.
more soluble magnesium, so I was expecting like the opposite.
Okay, that's a good question. So once it gets into it's absorbed through the rumen, it goes to the blood. So that's what we are going to consider that is absorbed. But because we were feeding it excess, it's going to go through the kidney. So the more magnesium shows up in the urine is because it went to the blood and then it left through the urine. If it went in feces, it will be a different thing, because in feces it will make it inside the animal. But if it goes through the urine, it made it inside the animal. Is that what you were asking? Or?
Yeah.
Okay.
Okay, thanks.
But thank you for the question.
Any other questions? Okay.
Yes, okay, go ahead.
And have you ever checked organic source of magnesium, or you can infer what's going to be the absorption in the same pathways of these was?
What we're going to do is in vitro, next test. Hopefully it reflects or is a little bit correlated with in vivo, but there are very few studies on magnesium in vivo.
In organic sources.
Yes, so we are going to do, now we are going to evaluate all the magnesium sources that we are finding. So you have a source that you want us tested and is not in the list?
Yeah, like glycinato, magnesium glycinate, or yeah, other organic source, not inorganic.
I don't think we have any magnesium glycinate.
Yeah, or something like
Where
that.
are you from?
Colombia.
Colombia. And are you feeding daddy?
Yeah, but not in cow.
Okay. We are still trying to increase the number of samples that we get here. We reach out, if anyone knows another way to reach out to feed mills and nutritionists so we can get more samples, that will be great. Thank you for your questions.
All right, thank you. When you stepped in, there was also the opportunity for a Yeti. I think you may have seen that. That is up here. What I'm going to do is I'm going to bring it back there. And if you want to enter for it, just drop your slip in there. That would be perfect. We do appreciate you joining us today, being a part of this. Thank you, Noelia.
Thank you.
Appreciate this. And again, enjoy your time at World Dairy.
Thank you.